So today we're going to be learning how to solve equations. We're going to do this in multiple ways. We're going to use the equations method to the left, and then we're going to use a visual algebra tiles method to the right. So our first equation, x minus 5 equals 4. If we look at it, if we had x be 9, we would get 9 minus 5 over here on the left is going to equal 4, and that would be the solution to our equation. So it's kind of easy to see that x would be 9. Now the thing is, we want to know how to solve for this. So what we're going to do is we're going to bring in 5 positive 1s to the left and 5 positive 1s to the right, because whatever we do to one side, we have to do to the other side. By doing this, that will create 0 pairs on the left side. Then those 0 pairs will just disappear and cancel out. On the equation side, what that's going to look like is the 5s will just cancel, and we end up getting x equals 9, which we can also see on the visual side where we have our x equals 9, and that's going to be the solution. Now we're going to look at a new equation. This one is 3x minus 4 is equal to negative 1. So we're going to do something pretty similar to this one. We have some x's on this side and numbers on both sides. So we're going to bring in 4 positives to each side so that we can get 0 pairs on the left. In doing so, that creates our 4 0 pairs on the left, and it creates 1 0 pair on the right. So all of those are going to disappear. This leaves us with 3x equals 3. Now, the thing to see here is there are going to be 2 ways to do this. The first way is using the equations, we just divide both sides by 3 to solve for our single x. In doing this, we get x equals 1, which would be the solution. Now, on the other side, we can see that each of the x's can be moved to coordinate with each one. So I can move the 1s so they align with the x's. That allows us to see that each x has one value that goes with it. So each single x would equal 1. So now we're going to look at our next problem. Our next problem is going to be negative 3x plus 2 equals 2. So we're going to do the same process we've done for all the other ones. And I'm not sure if you guys can see yet, but if x is 0, this whole term is going to be 0. And then we have 2 equals 2. Well, that's going to be true. So our solution is going to be x equals 0. But we want a way to show it. So what we're going to do is go over to our model at the right, and we're going to bring in negative 2 to both sides to cancel and create 0 pairs. When we bring in the negative 2 to both sides, we end up getting those 0 pairs, which are just going to cancel and disappear. What we're left with is 3x equals 0, which you can see both from the model where we have 3x is equal to nothing and from the equation part. So since we have nothing, you just give nothing to each of the x's and you can tell that x is going to be 0. Or from the model side, you can divide both sides by 3 equals 0. And that's going to give us our solution of x equals 0. Our next equation is going to be x minus 4 equals negative x plus 4. So this time we have x's on both sides and numbers on both sides. So what we're going to want to do is try to get x's on the same side and the numbers on the same side. I'm going to start by moving the numbers over. So I'm going to add 4 to both sides, positive 4, to get these to cancel and make 0 pairs. And when those cancel, what we'll have left is x on the left side and negative x plus 8 on the other side, which you can see from our equation too. So we're not done yet though, because we still have x's on both sides. So I'm going to want to bring in x 0 pairs. So I'm going to bring in a positive x to both sides to make this a 0 pair and making it cancel. After those 0 pairs disappear, we're left with 2x equals 8, which you can see on the equation part and the other part. So how we're going to do that is we want to divide the 8 evenly. So they're nicely in 2 rows as it is, but if they were organized differently, we want to make sure that it's the same. So what we can tell from this is each x bar is going to correspond with 4 1s. So as shown on the equation side, if you divide both sides by 2, we end up getting x equals 4, which you can see on this side too, because each x bar is going to have 4 1s in its row. The next equation we have is x plus 5 equals 2x minus 1. So this is a little bit more similar to the last one in that we're going to do something pretty similar. So I'm going to do the same thing, and I'm going to bring my numbers to one side and the x's to the other side. So what I'm going to do is I'm going to bring in 5 0 pairs, and I'm going to do that by bringing in 5 negatives to both sides, because what you have to do to one side, you have to do to the other side. My 5 0 pairs on the left are going to disappear, leaving us with x equals 2x minus 6, which you can see both from the visual and from the equation. So we're not done yet. We're going to bring in another set of 0 pairs. So I'm going to bring in 2 negative x's to try to get all the x's on the left side. And that'll bring them all over by creating 2 0 pairs on the right. This creates those 2 0 pairs on the right and also a 0 pair on the left. So all those 3 0 pairs are going to cancel, leaving us with negative x equals negative 6. So our last step is just going to be we want them both to be positive. So on the equation side, we're just going to divide by negative x on both sides. Dividing by this negative 1 will create x equals 6. On the other side, you can see that if a negative x is going to equal negative 6, if we just flip the signs of both of those, we'll get our positive x is going to equal our positive 6. And that is going to be our answer.